My name is Lady Cops, and you are welcome to my channel, OBJ Institute, once again. Today we are going to be looking at the series and parallel circuits. Please, I will endeavor you to watch this video from the beginning to the end because you don't want to miss any information given. Also, please don't forget to like, subscribe, and share. Okay, now we are looking at the series and parallel circuits. First of all, let's start with the series circuit. So these are an example of the series circuit. Now, before we move on, let me talk about this cell. Now, this symbol indicates that we have a cell here. Now, the longer part of the cell is the positive terminal, while the shorter part of the cell is the negative terminal. And as we all know, conventional current moves from the positive terminal to the negative terminal. Okay, now for the cell, our cell is 60 volts, while our resistance is 8 ohms and 12 ohms. Now, how do we know that this is a series connection? Now, we know this is a series connection. We know that series connection is an end-to-end connection. And also, another issue you understand is that in series connection, the current only has one path to move. That it only has a single path to flow. Now, the current will start from here. It will move around here, go to this point, down to this point. So you can see that it only moves in a single path. And in a series connection, the current that moves belongs to all the resistors. Okay, the current that moves belongs to what? To all the resistors. So the current does not change. Let's assume the current for this battery is 5 amperes. So therefore, the current flow will be 5 amperes all through this place. Also, the current that gets to this resistor will also be 5 amperes. The one that gets to this one is also what? 5 amperes. Please note that in a series circuit, the current remains the same. It does not change. Now, for series connection, there's also what we call total resistance or equivalent resistance. They are the same thing, but the examiner might want to convince you and ask you to calculate equivalent resistance. Please note that equivalent resistance is taken as total resistance. So your total resistance is equals to, how many resistance are we having on the board? We are having 2 resistance. So that will be R1, which is the first resistance, plus R2, second resistance. So therefore, we can say our total resistance equals to, the first resistance is what? 8. That's 8 plus the second one, 12. So my total resistance equals to what? 20 ohms. Mind you, you can write this as subscript T. You can also write it as Req. Req means equivalent resistance. Now, this is this. So that means the total resistance in this circuit is what? 20 ohms. While the voltage is what? 60 volts. Now, this 60 volts you are having in this series circuit, the one that is going to flow on this 8 ohms is different from the one that will flow on this one, 12 ohms. But we are told that the total voltage moved in this circuit is what? 60 volts. Now, before we move on, you can now go to what we call Ohm's law. Ohm's law. Ohm's law says that the current passing through a metallic conductor at constant temperature is directly proportional to the potential difference between its ends. Now, basically, what Ohm is just telling us is that our V, which is our voltage, is equals to your current times resistance. That is V equals to IR. Now, for the circuit, we are having our voltage given as what? 60 volts. We are having our resistance. So this R now will now represent the total resistance in the circuit, which is what? 20 ohms. Now, the current is not given. So we are going to calculate the current that flows around this what? Circuit. So we are going to use this formula, Ohm's law, V equals to IR. We have our V at 60 volts equals to I. That's what we are looking for. Then times I, which is what? 20. Now my 60 equals to 20 times I. That will be 20 I. And I'm looking for I. I'm going to divide this out by what? 20. So once I divide this out by 20, we have our I equals to 60 over 20. Our I equals to 3 amperes. Okay, so that means the current that flows through the cycle is what? 3 amperes. That is that. Now we can also go ahead and calculate the voltage drop in each resistor. Now we can calculate the voltage, that is, we want to get 50 volts for these two resistors. Now the first resistor is what? 8 volts. You can see that V equals to I R. Now we are looking for the voltage that will come to this 8 volts. Now my V will be equal to the current. Don't forget I told you the current is the same thing that flows around the series cycle. If we have more than 2 resistors, let's say we have 3, 4 resistors, the current is still what? 5 amperes. So currently we are using a series cycle. Now for this first one here, my V equals to I. What's the current? 3 times what's the resistance? 8. So we have my voltage equals 3 times 8 is 24. So that means the resistance here is taking the voltage of what? 24 volts. So basically, you don't need to calculate for this other one, but you can if you want. You can easily get it by subtracting this 24 from 60. But let's go ahead and calculate it. Now the voltage drop for these 12 volts, we are going to have V equals to IR again. So my V will be equals to 12 times 3. So my V will be equals to 36. So we are having here 36 volts. Okay, so that is the solution to this circuit. Now another thing I can make you to understand is my V equals to IR. Whenever our resistance increases, the voltage also what? Increases. Okay? Whenever resistance increases, our voltage does what? Increases. So please take note of that. Alright. So that's for the series. Now let's now come to the parallel connection. The parallel circuit. Now how do you differentiate between a series circuit and a parallel circuit? The difference is that series is end-to-end connection, while parallel is side-to-side connection. That is, the current does not flow in one path. If the current moves from here, so that the current drops to this resistance, it also continues journey and also drop to this resistance. That is, let's assume the current flow here is 5 amperes. Once it gets to this part, it's going to drop. That is part of that 5 amperes, it drops to this 12 ohms. So the remaining will now drop for this 16 ohms. So therefore, this becomes what? A parallel connection. Why? Because the current is not flowing in a single path. Okay, so for this one also, if you calculate total resistance for circuits in parallel, we are going to have 1 over RT equals to 1 over R1 plus 1 over R2. It can also be called equivalent resistance. Please don't forget that. So you can write it as 1 over R dq equals to 1 over R1 plus 1 over R2. Now, the difference between the series and circuit is that in the circuit, the current is the same, while the voltage is different, while in parallel connection, the voltage is the same. That is, the voltage that moves from the positive terminal they are what? They are the same. It does not change. But the current is what? Different. Yes. I think you can get the difference now. So this is for resistance. Now for this cycle, we need to calculate first the total resistance in the cycle, which is in parallel. Now that will be 1 over RT equals to 1 over the first resistance, which is 12 ohms, then plus 1 over 16. So you can go ahead and find your LCM of 12 and 16. But when there is also another formula we can use to calculate total resistance when we are having 2 resistors. Okay? When we are having 2 resistors, which is our RDQ equals to the product of resistance, which is R1 times R2 over total resistance R1 plus R2. We can use this, but we can only use this when the resistance are 2. If it's more than 2, we cannot use this. Go ahead and have our REQ equals to R1 times R2, that will be 12 times 16 all over 12 plus 16. So our REQ equals to 16 times 12, that should give us 1, 2 times 1 plus 1, 3, 4 times 6, is short as 1, that's 2, and that's 192. All over 12 plus 16, that's 28. So we can have our total resistance as, so let's divide this. We have 2 divided by 40. So that should give us 6.9 ohms. 6.9 ohms. We can also still go ahead and use this. Let's see if we are going to get the same thing. We have 1 over RT equals to. Now the LCM of 12 and 16. So we are going to have 2, that should be 6. Here is 2 can also go 3, 4. You can use 4 directly from here. This is 3, 1. 3 can also go 1, 1. So we have 2 times 2, 4. 4 times 1, 16. 16 times 3, 48. So our LCM is 48. So we have 48 divided by 12. That will give us 4. 4 times 1, that will be 4. Plus 48 divided by 16, 3 times 1. We have 3. So we have 1 over RT equals to 12. Sorry, that should be 7 over 48. So if we cross multiply, we have our RT equals to 48 over 7. So what will this give us? By 7, that should still the same thing, that's 6.9 ohms. So you can see that either you use this formula or you use this, you're still going to get the same value. But please, you are only using this when the resistors are 2. But you can use this when the resistors are more than 2. So you can go ahead and have 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. Yeah. So that's that. So we have gotten the total resistance. Now we can now get the current, okay, for the circuit. You can get the current that drops in each resistance, or you can just try to get the total current. Still using our own stock formula, which says V equals to I R. Now for this one, what's my voltage? That's 48 equals to I, which is what we are looking for, times R. There's the R, nothing there, times 6.9. So my current equals to 48 divided by 6.9. So let's see what we have. 48 divided by 6.9. So it's giving us the same thing as 6.95 amperes. Okay, so that's the current that goes from for the first resistance and second resistance. So we can now go ahead and divide the current for both resistance. Okay, we can do that. Don't forget the voltage remains the same. So the voltage that moves around here, that comes here is also 48. The one that comes here is also 48. So that's 48. There's also 48. So we can go ahead and use this to calculate the current. So the current for this one that just for this one would now be you see V equals to IR and I equals to V over R. So my I will be equals to what's our V? That's 48 and my R, that is 12. So my I equals to 4. So that means the current here is 4 amps. Now current for this one, I equals to V over R. I equals to 48 over 16. So my I equals to 3 amps. So now the current drop there is 3 amps. Okay, so you can see, and the total current we have was 6.95, which is equivalent to 7 amps. So if you add this 4 and 3, you see that we have a total of 7 amps. So please, in your exams, if you are asked the current, the voltage, what will be the voltage for the 12 ohm resistor? The voltage for the 12 ohm resistor is what? 48 volts. Why? Because it's a parallel circuit. Okay? So thank you. If you have any question, please drop it in the comment section. And also don't forget to like, subscribe, and share. Thank you.